Okay. We are going to study another concept in a lattice. That is the Boolean lattice. Okay. So what is meant by Boolean lattice here? So a complemented distributive lattice is said to be a Boolean lattice. Okay. But that is a lattice which is a complement as well as Boolean as distributive lattice. Then such a lattice is said to be a Boolean lattice. Okay. So we repeat another definition. So a complemented distributive lattice is said to be a Boolean lattice. Okay. So you see the notes. So since Boolean lattice is a complemented lattice, so by definition of complemented lattice, you can say that so every element a lattice is said to be complement if only a latticeal is said to be complement if every element in lattice has a complement. Okay, so we can say that since the Boolean lattice is a complement, then we can say that the least element 0 and the greatest element 1 is always exist in a Boolean lattice. Okay, so by definition of complementary lattice, we can say that the least element 0 and greatest element 1 is always exist in a Boolean lattice. Okay, so similarly we can show. Next we see the notes. So since Boolean lattice is distributive lattice, this will what is distributive lattice here? Lattice is said to be distributive if satisfy the distributive law. The people say that in a Boolean lattice, distributive laws holds in a Boolean lattice. Okay, which is important. Upon we see the next example here. In a Boolean lattice, okay. And what is this Boolean lattice here? So Boolean lattice is what is by definition of Boolean lattice? So Boolean lattice is a complemented distributive lattice, and we know that in a complemented distributive lattice, so De Morgan's law holds. Okay, so we can say that in a Boolean lattice, De Morgan's law is always holds. Okay, De Morgan's law is always satisfied in a Boolean lattice. Okay, so suppose I take one of the example here. This is the example. We have to show that this diagram. This whole diagram is a Boolean lattice. Okay, this is a whole diagram with the least element 0 and greatest element is 1. We have to show that this is a Boolean lattice. We can show that it is a complemented lattice and stressed by the distributive law. Okay, so first we show that it is a complemented lattice. Okay, so from figure, if you clearly observe that this from figure here, so clearly from figure we can say that given lattice is a complemented lattice. Okay, what is a complemented lattice? If every element in lattice has a complement. Okay, म्हणजे त्या लॅटिस मध्ये प्रत्येक एलिमेंट जर त्याला काय असेल कॉम्प्लिमेंट असेल, we can show that this lattice is a complemented lattice. Okay, so if you clearly observe that, okay, what is okay? We take one example. Okay, so here B, what is B met E? So B met E is equal to here 0 and B join E. Okay, so B and B join by is the 1. So we can say that B and E are complement to each other. So similarly we can show that from this whole diagram we can show that every element has a complement. So by definition of complement lattice we can show that this lattice is a complemented lattice. Okay, so similarly and what is here? So from here we have to show that check whether this lattice is distributed so or not. Okay, so we take A meter B join C. Okay, what is B join C here? Actually here this is a 1. So A meter 1 is equal to 1, and similarly A meter B join A meter C. What is A meter B here? Okay, A meter B join A meter C. What is A meter B here? So A meter B is equal to 1 and A meter C is equal to 1. So therefore we can say that A join C is equal to 1. Then we can see that the A meter B joins is equal to A meter B joins A meter C. Therefore we can see that the given lattice is the distributive lattice. Therefore we can show from 1 and 2 we can show that the given lattice is a distributive lattice. Therefore this lattice is a complemented as well as distributive. Therefore we can see that this lattice is a Boolean lattice. Okay, Okay, so we have to show that next theorem. Let here be a Boolean lattice, then 0 dash, what is 0 dash here? Complement of 0. So the complement of 0 is 1 and the complement of 1 is a 0. Okay, we have to show that. So 0 dash because that A dash denotes the complement of A in lattice L. Okay, so here if L is a Boolean lattice, then we can show that the complement of 0 is 1 and the complement of 1 is a 0. Okay, so we have to put this theorem. So let L be a Boolean lattice and 0 is the least element and 1 is the greatest element of lattice L. So now consider, we need that. So then what is here? 0. So 0 is the least element and 1 is the greatest element in lattice L. Okay, so now consider 0 meet 1. What is meet of 0? So 0 meet 1 is here. So 0 meet 1 here is equal to 0 and 0 join 1 is equal to 1. Okay, then we can say that. So by therefore, okay, therefore by definition of complement, you can say that 1, what is here? 0 meet 1 here? 0. Okay, and 0 join 1 is equal to 1. So that we can say that 1 is the complement of 0 in lattice L. That we can say that the complement of 0 is equal to 1. So similarly, if you clearly observe that here, so you know that lattice is the distributed commutative lattice. Okay, so if we write in here 1 meet 0 is equal to 0. Okay, by the commutative property, this commutative is given by here, and if you write 1 join 0 is equal to 1. Okay, so we can similarly we can show that 0 is the complement of 1 in lattice L. That we can see that the complement of 1 is equal to 0. So we can show if L is a Boolean lattice, then the complement of 0 is 1 and the complement of 1 is equal to 0. Okay, so we see next here. Let L be a Boolean lattice, then the complement, this what is here? Double complement. If you can write here complement of complement. Okay, so here what is complement of complement? You can write here double complement. Okay, sure the complement of complement is always itself A. Okay, the complement of element A is equal to itself A. Apply that to show for itself. Okay, so let L be a Boolean lattice and A be an element of L. Then so as L is a Boolean lattice, then it is a complementary lattice. Then L is a complementary lattice. We can show that. Therefore, by definition of complement, every element has a complement. So therefore there exists say A dash in a L such that therefore there exists a complement of A, say A dash such that A dash meet A is equal to 0 and A dash join A is equal to 1. So that we can say that A dash is the complement of A. Okay, therefore here A dash is the complement of A in lattice L, and therefore in lattice L commutative law is holds. Therefore we can write here this A dash meet A is equal to, I can write here A meet A dash is equal to 0 and A dash join A, I can write here A join A dash is equal to 0. Okay, so from this equation we can show that A is the complement of A dash. Okay, here we can say that here by definition of complement, here we can say A is the complement of A dash in addition. So we can say that the complement of complement is equal to A. So that we can say that the complement of complement is equal to the complement of element A is nothing but it is itself A. Okay, so for all the elements of lattice L. Okay, so we next see the next conclusion. Okay, so let L be Boolean lattice, then we have to show that A meet B is equal to A complement join complement of this complement. Okay, म्हणजे याचा complement जो असेल म्हणजे the complement of A join. Okay, what is this here? The complement of A dash join B dash is equal to A meet B, and the complement of A complement meet B complement is equal to A join B for all the elements of lattice L. Okay, so we produce here. So that let L be Boolean lattice, thereby D Morgan's law is holds by the integral by the complement of A meet B is equal to A complement join B complement, see the equation 1, and the complement of A join B is equal to A complement meet B complement, see the equation 2 for all the elements of lattice L. Okay, so we have to take now consider. So now consider here A complement join B complement meter okay. So now consider A complement join B complement meter A meter B is equal to okay. So by definition of what is okay? What is by equation 1? What is equation here 1? So what is actually what is A complement what is A complement join B complement here? So is equal to here A meter B complement. So because by equation 1 you can see that A meter B complement meter A meter B. What is this here? So A, this is a complement of A meter B. Therefore by definition of complement you can say that the meter of these two elements is equal to 0. Okay. And similarly here A meter A complement join B complement join A meter B. So again by equation by De Morgan's here we can write here A meter B complement join A meter B. So this is the complement of A meter B. By definition this join is equal to 1. Okay. So we can say that A complement join B complement, this element A complement join B complement is the complement of A meter B lattice cell. That we can say that. So therefore we can say that the complement of A complement join B complement is nothing but is the A meter B. Okay. So similarly we can show and so second theorem, second condition here. So now consider A complement meter B complement meter A join B. So by De Morgan's theorem here, what is this complement here? This element is by De Morgan's second law you can say that A join B complement meter A join B. What is this? This is a complement of A join B. Then we take a complement meet this element. Can we get by definition of complement? It is a 0. Okay. So similarly we can show that A complement meter B complement join A join B is equal to, so again by De Morgan's second law, what is this actually? This is a join B complement join B A join B. What is this? This is a complement of A join B. And we take join. So by definition of complement, their join is equal to 1. Okay. So we can see that A complement meter B complement is the complement of A join B in lattice cell. If you can say that the complement of A complement meter B complement is the same as the A join B. Okay. So we put this result, which is important here. So next we see the next result. Okay. So that here be a Boolean lattice, then A meter B complement is 0 if and only A is related to B for all the elements of lattice. Okay. We have to show that this is okay. A meter B complement is 0 if and only A is related to B for all elements of lattice. Okay. So that here be Boolean lattice, then it is a complemented and distributed lattice. Okay. So let what is here? Let B dash be a complement of B in lattice cell. So by definition of complement, so B meter B complement is 0 and B join B complement is equal to 1. Say the equation 1. Apply it correctly. So we take this assumption here. B meter B complement is 0 and we prove that A is related to B. Okay. So now consider here. So B join A meter B complement. Okay. So what is L is distributed to? If you consider that join is distributed to what? This join is distributed to what means we take B join A meter B join B complement. What is the B join B complement here? By definition is 1. If you can take B join A meter B complement, therefore this complement of the meter of B join A and 1 is B join A. By a common rule we can write that A join B. So equation 3. Okay. So what is here? And what is A join B mid complement? What is B A join? Sorry, yeah. B join A meter complement. What is A meter B complement here? So A meter B complement is 0. So we can write here, and therefore B join 0 is equal to B. Okay. So when we get what is B join 0 is equal to B. Okay. So we clearly observe that here, as LHS are equal, so we can see that RHS are also equal. So for equation 3 and 4 you can see that A join B is equal to B. Okay. So this shows that the join of A and B is B, and this gives the relation. We can say that this implies that A is related to B. That we can show that if if we show if A meet B complement is 0, then we should have A is related to B. So we take a conversely suppose that A is related to B for all elements potential. So then by definition we can say A meet B is equal to A and A join B is equal to B. Okay. So now consider, and we claim that A meet B complement is 0. So now consider A meet B complement here. So by taking absorption law for B complement, I can write here A meet A join B meet B complement. Okay. So sorry. So we take absorption law for A. Okay. So I can write the absorption law for A. We can write here A meet A join B meet B complement. Okay. So we take a complement is associative. We can write here A complement. Sorry. A meet A join B meet B complement. Okay. Okay. So what is as A is related to B? So we can take what is A join B is equal to B. So therefore we get A join B is equal to B. So this will be the result. A meet B meet B complement. What is the B meet B complement here? 0. Then we can say that meet of A and meet 0 is equal to given by 0. Then we can say that A meet B complement is 0. Therefore we prove if A is related to B, then we have to show that A meet B complement is equal to 0. Okay, which is important here. So we see the next result. Okay. Similarly, let here be a Boolean lattice. Let here be a Boolean lattice. Then A complement join B is to 1 if and only if A is related to B for all elements of lattice. Okay, we should repeat here. A complement join B is 1 if and only if A is related to B for all elements of lattice. Okay. So let L be Boolean lattice. Then we can say by definition L is a complemented and distributive lattice. Okay. So let A complement. What is A dash? So A dash is the complement of A in lattice L. So by definition of complement you can write here A complement join A is equal to 0 and A complement meet A is equal to 0 and A complement join A is equal to 1. Say the equation 1. And what is your let? We suppose that let A complement join B is equal to 1. Say the equation 2. Then we prove that A is related to B. Okay. So now consider here. Now consider A meet A complement join B is equal to, okay. So we take a absorption law. Okay. By we can say by the L is distributive, we can say meet is a distributive or join. So therefore by distributive lattice we can say that A meet A complement join A meet B. But what is A meet B? What is A meet A complement here? Join by equation 1 0. Therefore we can say that 0 meet A meet B. Okay. Therefore 0 meet A meet B is equal to here A meet B. Say the equation 3. Okay. We take now consider and what is here A meet A complement join B. Okay. What is A complement join here? 1. We have to give equation by 2. If you take A meet 1, what is the meet of A and 1 is A? Okay. By okay, we can say the equation 4. So as the LHS are equal, then you can see that RHS also equal. Then you can from equation 3 and 4 you can see that A meet B. Okay. So A meet B is equal to A. Because this should have the so infimum of A and B is A. With this gives the relation, we can see that A is related to B. Okay. So we prove if A complement join B is 1, so we prove that A is related to B. Okay. So similarly we prove that here. Conversely suppose that, okay. So conversely suppose that A is related to B for all elements like this here. Okay. Then by this theorem we can see that the meet of A and B is A and the join of A and B is B. Okay. So now consider we have to show, we prove that A complement join B is 1. So okay. So now consider A complement join B. So we use the distributive absorption law for B. That is given by A complement join B join B meet A. Okay. By absorption law. So again here we can write here by commutative law we can say that by commutative law we can so B meet A, I can write A meet B. So if we get A complement join B join A meet B. Okay. So again here What is A into B? So A into B is equal to A. So you can use here A complement join B join A. So by associative law for join you can use here A complement join B join A. Again by use of commutative law you can use here A meter A join B, and by you can use the associative law for join we get A complement join A join B. So what is here? A complement join A is equal to 1. Okay, this is use relation. So you can the join of 1 and B is 1. Okay, the previous show that if A is related to B, then we show that A complement join B is equal to 1. Okay, which is important here. Okay, so next we show. So therefore we show that A complement join B is 1 for all elements lattice cell. Okay, so let we theorem through the theorem here next. So let L be a Boolean lattice. Then we have to show that A with the B complement is 0 if and only. Okay, what is given here? L is the Boolean lattice. Then we have to show that A with the B complement is 0 if and only A complement join B is 1 for all the elements of lattice L. Okay, so here, so let L be a Boolean lattice. Then we can show that then in Boolean lattice we know that A is related to B if and only अपन जो मार्के दोनों theorem अपन इतने बदली. So we use the these two previous theorem. Okay, so we know that. So in Boolean lattice we know that A is related to B. A is related to B family. A with the B complement 0 for all elements of the cell, and similarly A is related to B family. A complement join B is equal to 1 for all equation 1 elements of the cell. Okay, so here we from equation 1 and 2. Okay, if these two RHS are equal, then we can say these LHS are also equal. Okay, if only condition. Okay, so then we can say that by equation 1 and 2 you can say that A with the B complement is 0 if only A complement join B is 1 for all elements of lattice. Okay, so we prove that this result. Okay, then we see the next result. So let A be a Boolean lattice. Then A is related to B. Let L be a what is L? Let L be a Boolean lattice. Then we prove A is related to B if and only B complement is related to A complement for all the elements of lattice L. Okay, so let L be Boolean lattice. Then by definition of Boolean lattice we can say that L is a complemented lattice as well as distributive lattice. Okay, so let A complement and B complement are the complements of elements A and B in lattice L in respectively. Okay, you can say that A dash is a complement of A and B dash is a complement of B in lattice L. Okay, so then we prove that. Let we take A is related to B. Then by definition we can show that the infimum of A and B is A and the supremum of A. So we can say that A into B is A and A join B is equal to B. Say the given equation 1 and say the given equation 2. Okay, so we can say that we know that De Morgan's law is holds for Boolean lattice. So taking complement on both sides of equation 1. Okay, आता equation 1 जर equation 1 का देखेंगे तो complement आपण देखेंगे दोनों साइड देखेंगे तो we get so we can say A with B complement is equal to A complement, but by De Morgan's law, therefore by De Morgan's law we can say here what is the A with B complement. Here we get A complement join B complement is equal to A complement. So this shows that the join of A complement and B complement is A complement is equation 3. Okay, so similarly we take a complement on both sides of equation 2. So we get the A join B complement is equal to B complement. So again by De Morgan's law which is there, and what is the complement of A join B here? Is nothing but it is the A complement with B complement is equal to B complement. This shows that the infimum of A complement and B complement is B complement, and this is the supremum of A complement B complement is A complement. Therefore, by definition of supremum and infimum, you can say that by equation 3 and 4 we can say that आपण equation 3 and 4 मध्ये आपण असं म्हणू शकतो, we can say that B complement is related to A complement for all the elements of lattice L of A. So conversely, suppose that B complement is related to A complement for all the elements of lattice L. Then by definition we can say that B complement with A complement is equal to B complement, and B complement join A complement is equal to A complement. Okay, so taking complement on both sides this equation, we can say that B complement with the complement of B complement with A complement is equal to this is the complement of complement. Okay, we know that the complement of complement is equal to B, so see this become a B. Okay, so again by using De Morgan's law for this complement, so we get a complement of complement B join complement of complement A is equal to B by De Morgan's law. So what is the complement of complement A is equal to A, and complement of complement B is equal to B. So connect here B join A is equal to B. That is by commutative law we can say that A join B is equal to B. Okay. So next, similarly we can show that okay. So taking again a complement on this board equation, we get the complement set equation 5. The complement of B complement join A complement, we get a complement of complement. Okay. So again by De Morgan's law for complement, we can write here this gives a complement of complement B meet a complement of complement A is equal to complement of complement A. Okay, what is the complement of complement A here? A, and the complement of complement is equal to P. So we can write here B meet A is equal to A. So by commutative we can say that A meet B is equal to A. Okay, so if you equation 5 and 6, if we observe that the join of A and B is B, and from equation 6 we can see that the meet of A and B is a B. So therefore from equation 5 and 6 we claim that A is related to B. So we can see that A is related to B. So therefore we prove the result here. If A is related to B, so we prove the result here. A is related to B if and only B complement is related to A complement for all the elements of lattice L. So therefore we prove in this way we prove this theorem. So in this way we complete our syllabus of lattice theory. आपण या ठिकाणी अशा पद्धतीने आपण लॅटिसचे संपूर्ण 5 युनिट जे आपल्याला दिलेले 5 युनिट होते, संपूर्ण 5 युनिट आपण या ठिकाणी आपण संपवलेले आहे. या ठिकाणी आपला लॅटिस थेरीचा सिलेबस या ठिकाणी संपलेला आहे. ओके, सो थँक यू अँड बेस्ट ऑफ लक फॉर एक्झामिनेशन. ओके, थँक यू, गुड बाय.